All right, here we are at sampling methods. Why do we have sampling methods? Why is it important? Well, we need to ensure we sample correctly so that we're adequately representing the population of interest, and we're doing so without bias. So there are 4 good sampling methods we're going to talk about and 1 that's not great. So the very first one is a simple random sample. You are never going to see me write that out. I'm always going to abbreviate it, and this is common practice in all statistic books, lessons, videos, everything you can see. We always call it an SRS. So what does it mean to be an SRS? Each individual item must have an equal chance of being selected, and each combination of items also has to have an equal chance of being selected. I'm not going to lie to you. On your multiple choice, this is going to kill you, because guess what? On the test, there's a multiple choice question, and there are 2 right answers, but one of them is more right because it talks about the combination of items as well. So please keep that in mind when you get to that problem on your test. Now we'll be able to see who's listening to their videos. Oh yeah, baby. Okay, the next sampling method we're going to talk about is a stratified method. Stratified is to surveying and sampling what blocking is to experimental design. There's some characteristic in the population that we believe might affect our results. So we divide our population into homogeneous groups called strata, and then we take an SRS from each of those strata. Okay, so of course this always helps reduce our variability. We don't want our answers to be all over the place. We want them kind of narrowed down so that it will actually tell us something about the population. Okay, the next one is called a cluster sample. Now, a cluster sample, a lot of students get these mixed up with stratified because we do split the population into parts or clusters, but we don't do it based on any characteristic within our individuals. We do it based on location or sometimes grouping as far as where it's located. For instance, if I wanted to cluster sample at school, I would look at classrooms and I would choose classrooms randomly, and then I would take a census within all of the ones that I chose. So we're going to talk more about these. Don't have a freak out attack. All right. The next one is systematic, and as the name implies, it has a system to it. And this just means that we almost always make a list of some kind from our population, and we choose a random starting point, okay? And then we systematically choose every 10th one or 7th one or 5th one or whatever, depending on the situation. So that's what a systematic sample is. Our convenience sample is the poor method. The example I used in my bias video when I was talking about what that would look like if I took a sample of students, if I just looked at my 7th period. Well, my 7th period, while it may be easy to survey those kids because I'm with them every B day, or any of my students, it would be easy to sample from you guys, but it's not going to be necessarily representative of the whole school. So that would be an example of lazy sampling. Okay, we also have multi-stage sampling, in which we combine several different methods together. So these are most often used by people who can afford it, like polling agencies like Gallup, places like that. They often use multi-stage sampling. All right, keep in mind that when we take a random sample, we're going to do repeated sampling in our population so that we get a really good idea and a good mix of our population, just to make sure that our sampling methods are we've chosen wisely and that we are going to be representative of the population. So if I take repeated samples, I'm not going to necessarily get the same sample each time, and this is called sampling variability. It's normal, it's expected. It's actually a little desirable just because not everybody's going to answer exactly the same way. So variability is what gives you a shape to your data. So we do expect it, and it's totally okay. A little bit. We don't want a huge, we don't want our sampling to look like this. Like, we don't want it to be that spread out. But some variability is natural and expected. Okay, so when we talk about surveying and sampling, we always want to make sure that we hit our target. And what does that mean? Well, that means that whatever my population of interest is, I'm hitting that. I'm making sure that I am choosing for my population of interest and that it represents it well. So when we're hitting the target, that means we've got low bias, which is what we want. We can't eliminate bias, but we can do a good job of eliminating a lot of it. Now, we also want our sampling to be a good representation. Okay, we want it to represent our population well, and we can tell it's doing that if we have low variability. So ideally, what we want is we want to target our population correctly, and we want a good representation of our population. So we want low variability, low bias. So target C, that's the sweet spot right there. I've got all of these points in the center. That means our target's being hit and they're not very spread out. So that means it's a good representation of my population of interest. If one of these has to be sacrificed, variability or bias, it always has to be variability. We would rather see target B than target A or target D, because I want you to notice that on target A, that's the center and there's nothing there. And on target D, this is the center and there's nothing there. Neither one of those are acceptable because neither one of those are hitting my population of interest. Okay, so even though this one has got less variability, those points aren't as spread out, and this one's got more variability, it doesn't matter because we're not hitting the target of interest. So those are both unacceptable targets. Target C is ideal because it's got low variability, low bias. Target B is acceptable, but it's not as pretty as target C. So this is acceptable because you're still hitting the target, but man, we're all over the place. All right, so maybe not a great representation of your population, but better than A or D.